Alright, so now we are in 9.2, which is inconsistent and dependent systems and their applications. Here's our objective. We're going to use a calculator along with matrices to solve systems without unique solutions or with more variables than equations. So basically we're looking for no solution and infinitely many solutions. So let's go ahead and go straight into our books on page 885, and we're going to look at problems 1 and 21. So number 1, it says use Gaussian elimination to find the complete solution to each system of equations or show that none exists. We're going to bypass Gaussian elimination and use our calculators instead. So we have 5x plus 12y plus z equals 10. And then we have 2x plus 5y plus 2z equals negative 1. And then we got x plus 2y minus 3z equals 5. And we want to solve this system. So the first thing we need to do is write it as an augmented matrix. So let's go ahead and do that. So we should have 5, 12, 1, vertical bar, 10. And then we have 2, 5, 2, negative 1. And then we have 1, 2, negative 3, 5. So this is our augmented matrix. Now make sure that your x's are lined up, your y's are lined up, and your z's are lined up. And there's nothing but constants on the right side. Now the second thing we need to do is go ahead and input this in our calculators. So let's go ahead and turn our calculators on. And let's get inside the matrix menu. Scroll over to edit, hit enter. Now this has 3 rows, so 1, 2, 3. And it has 4 columns, 1, 2, 3, 4. So it's a 3 by 4. So hit 3, enter, 4, enter. And let's input this matrix. So we have 5, enter, 12, enter, 1, enter, 10, enter. Okay, once you input the last 5, you hit 5, enter. At that point, you should be able to use your cursor to scroll left, right, up, down to verify that you've inputted all of the elements incorrectly. Especially check the signs, the negative ones. Make sure you have them as negative. Once you have that, make sure you hit second, quit. You need to get out of that matrix. Now let's get back inside the matrix menu. This time scroll over to math. Then scroll all the way down to RREF, row reduced echelon form. On your screen, it should say RREF with a parentheses open. Is waiting for you to tell it what is the name of your matrix. So get inside your matrix menu once again. You should be under the names, and I always deal with matrix A. So I just hit enter. And I'm going to hit enter again once I'm on the home screen. And we get the following matrix. Okay, now they don't put the vertical bar here, but we can because we know this last column are constant, so your vertical bar has to be right there. Now let's write out the solution. So remember, this is the x column, the y, and the z. Now how you know it's x, y, z? Because they have x, y, z. Alright, so the first equation says 1x, so x, minus 19z equals 0. Notice that we bypassed over y because its coefficient was 0. And then the second equation says y plus 8z equals 0. And then the last one says 0x plus 0y plus 0z, which means, what do I have on the left side? Just 0 equals 1. Now this is where we pause, because can we have 0 equaling to 1? Is this possible? The answer should be no, which means it doesn't work here, which means how are you going to be able to solve the rest if it doesn't work for the last equation? Therefore, your answer is no solution. So if you ever have a row that has zeros on the left side of the vertical bar, so these are all zeros, and then you have a non-zero constant here, the answer will be no solution, because it's impossible for 0 to equal a non-zero constant. In our case, it was 0 is equal to 1. It's not possible, so it's no solution. All right, let's move forward. Let's look at number 21. So we have the system w plus x minus y plus z equals -2. And then we have 2w minus x plus 2y minus z equals 7. And then we have -w plus 2x plus y plus 2z equals -1. And they want us to solve this system. Now notice that you have 4 variables, but only have 3 equations. If we had to solve this by hand, we have to have a match. The number of variables will have to match the number of equations. So if we had 4 variables, we will have to have 4 equations. So let's see how our calculators do. So the first thing you need to do is make an augmented matrix. So we have 1, 1, -1, 1, vertical bar, -2, and then let's fill in the rest. Okay, so we have our matrix. So now the second thing we need to do is go ahead and input this into our calculator. So get into your matrix menu, scroll over to edit, hit enter. And what do we have here? We have 3 rows. And how many columns? There's 5 columns. So this is a 3 by 5. So type 3, enter, 5, enter. And you should be down inside your matrix, and now you can change it, right? So we got 1, enter, 1, enter, -1, enter, 1, enter, -2, enter. All right, let's input the rest. Once you hit the last enter, so in this -1 enter, at that point you use your cursors to check over yourself, especially check the negatives. Since there's so many in here, check your negatives. Once you're satisfied with your matrix, hit second, quit, get back to the home screen. Now you need to get back inside your matrix, so get back inside your matrix menu, scroll over to math, then go all the way down to RREF, or row reduced echelon form. Get back inside your matrix menu once again. You should be under names, and I always just hit enter because I only deal with matrix A. Hit enter once again, and you receive the following matrix back. And we have 1, 0, 0, 0, 1, which means our vertical bar must be right here. And then we have 0, 1, 0, 1, negative 1. And then 0, 0, 1, 0, 2. Okay, so now let's write out our solution. So I like to always write the variables above the columns. The first one is a W, an X, a Y, then a Z, and these are our constants. And remember that this vertical line represents the equal. So our first equation is W equals 1. All the other variables are zeroed out. The second equation says X, remember that's a 1 underneath X, plus Z equals negative 1. And then the last one says Y equals 2. Awesome. Now, notice that we have equations that tell us something about W, X, and Y. Because I can solve this second equation for X. So let me change the color of my pen. So I can solve this second equation for X by subtracting Z on both sides, right? So in reality, this will become X is equal to negative Z minus 1. So we know W equals 1, X is equal to negative Z minus 1, and Y is equal to 2. But the only problem is we don't have a row telling us anything about Z. Usually we should have 4 rows down here and we should have something about Z, but there is nothing about Z. We don't have an equal sign, which means Z is free to be whatever you want it to be. Okay? Now, I like to write him as Z equals Z. That tells me that he can be whoever he wants to be. Z is equal to Z. Your book refers to it as a T, and they tell you T is any number. Okay? So in that case, we say Z equals T, which means he can be anything. So if I was to write out this solution in alphabetical order, well, W is equal to 1. X is equal to negative Z minus 1. So if you replace the Z with a T, X is equal to negative T minus 1. Y is going to be 2. And then what is Z? It is just T. And remember, T is just any number. And this is your solution. So let's say T was equal to, so for example, let's say T was equal to 3. Well, in that case, our solution would be 1, and then we'll put 3 in for T, and we'll get a negative 4 for X. Y is still going to be 2, and then Z would actually be 3. And if we said T was going to be 0, then our solution would be 1, negative 1, 2, comma, 0. So basically, how many solutions do we have here? We have an infinite amount. So it's an infinite amount of solutions here. And that's only because Z is free to be any number. So be careful. Some calculators would input a last row here, and that last row would be all 0. So depending on what kind of calculator you have, your calculator could have told you that for the last row was all zeros, which means in that case you have 0 equals 0. And since it is the last row, it's talking about the last variable, which is Z. So that's another way of saying Z can be whatever it wants, because you're writing, let me write it over here, you're writing 0 equals 0, and that is true, right? So that means Z is free to be anything. I normally write it as Z is equal to Z, but your book uses a different variable, so you can use the variable T. Okay, so let me go back. Notice for this solution, the last row has zeros on the left and a non-zero constant on the right. So that told us that 0 equal 1, which wasn't possible, so it's no solution. Now, even though the first and second equations were written in terms of z, we didn't have a value for z. Therefore, it was a no solution. And let's go forward. For this problem, I'm going to, where's my red? Oops. For this problem, we received the following matrix in red. And when we wrote out our solution, we noticed that we were missing a z. This tells you that z is free to be anything. So I usually write it as free. When I say free, it means he can be 2, 4, 5.9, anything. A million? Not really, but could have been. Okay, so z is free to be anything. And then when you plug it into your solutions, you'll end up with a point that actually has a variable written in it. And that means you have an infinite amount of solutions. Okay, so pay attention to the last row. If you have a last row of zeros, you should expect an infinite number of solutions. If your last row has zeros on the left side and a 1 on the right side, it's a no solution. Alright, so this concludes the video for 9.2. Please email me if you have any questions.